Hello, this is Mr. Best. Welcome to Chapter 5, Completing the Triangle Toolkit. We're going to start with questions from Lesson 5.1.1, 7 through 12. Question 7. You now have multiple trig tools to find missing side lengths of triangles. For the triangle at the right, find the values of x and y. Use your triangle toolkit to help you. Which tools did you use? Alright, let's go ahead and get started here. We have whichever one we want to look at first. Let's just start with x. And since we're looking at the 47 degrees, this side is the adjacent side. Just to work on some of that terminology, the y is the opposite side. So for this one, we would use cosine. And remember the abbreviation for cosine is COS. And this would be cosine of 47 degrees will be equal to the ratio of x over 11, which is the hypotenuse. So we have adjacent, opposite, and then the side across from the right angle will always be your hypotenuse. It's the longest side. So we can figure out what cosine of 47 is, and then once we figure out that value, we can multiply both sides by 11. And so x is equal to whatever 11 times cosine of 47 degrees is, and we will approximate that once we plug it in. And so we get x is approximately 7.50, and this will just be in units. So that would be the x value. And then to find the y, we'll be using opposite, so that would represent sine, as sine is abbreviated SIN. So it's sine of 47 degrees is equal to the opposite side, which is y, over the hypotenuse of 11. And so once again, we can solve this one the same way. We'll multiply both sides by 11. And so the exact answer is whatever 11 times sine of 47 degrees, but we'll plug that in our calculator and get an approximation. And so 11 times sine of 47 will give us a value of 8.04. So 8.04 units for y. So it does say which tools did you use. I used the cosine and sine functions. Could have possibly, after finding the value of x to be approximately 7.50, we could have used Pythagorean theorem to figure out the y value from there. We could have even found this angle down here and used that angle for sine or cosine as well. And then potentially could have also used the tangent ratio or the tangent trig function once you found one of the sides. So lots of possibilities there. I just chose to use cosine and sine of the information that was given to us, which was the 47 degrees. Question 5-8. Lori has written the conjectures below. For each one, decide if it is true or not. If you believe it is not true, find a counterexample, an example that proves that the statement is false. Question A. If a shape has 4 equal sides, it cannot be a parallelogram. And so that would be false, but we have to give a counterexample to that. There's a couple we could use. Square would be one that has 4 equal sides, but it's still a parallelogram. And the other one that we could write down is a rhombus. A rhombus has 4 equal sides, doesn't have the right angles like a square, but that would also represent a parallelogram. So once again, make sure you give a counterexample if it's false. On part B, if tangent of theta is more than 1, then theta must be more than 45 degrees. And that is a true statement. And if you can go back and look at your toolkits to kind of refresh your memory on that, but remember, tangent of 45 degrees is 1. Anything less than 45 would be less than 1, and tangent of anything more than 45 is going to be greater than 1. So if tangent of theta is more than 1, theta must be more than 45. Part C, if 2 angles formed when 2 lines are cut by a transversal are corresponding, then the angles are congruent. So if 2 angles form when 2 lines are cut by a transversal. Now, one piece that's missing here, it just says when 2 lines are cut by a transversal, then the angles are congruent, and that will be false, because the way that they would be congruent is if they were 2 parallel lines. So these 2 lines would have to be parallel. And so I drew a little picture to kind of show those corresponding angles. You can see that they're not going to be congruent because the two red lines are not parallel. Question 9, multiple choice. In the triangle below, x must be what? So if these two sides are congruent, then that means the angles must also be congruent. So what must x equal? This would be 2x plus 42 degrees should equal 180. So if you subtract 42 from 180 degrees, that's 138. And then you can divide by 2. And x is equal to 69 degrees, so the answer is B. Question 10. Susanna is drawing a card from a standard 52 card deck. Click playing cards to learn what playing cards are included in the deck. Okay. What is the probability that she draws a card that is less than 5? So we know there's 52 cards in the deck. We need to draw a card that's less than 5. So how many cards do you have less than 5? You have 2, 3, 4. It just says less than 5, so not including 5. So 2, 3, and 4. And then there are 4 different suits. So 3 times 4 would be 12. So 12 possibilities out of 52 would be a card less than 5. And if you decided to include aces, because you were thinking maybe when you play cards that means a 1 or something like that, then you would have actually said 16 out of 52. So maybe you need some clarification as to whether an ace would be included or not. Part B, what is the probability that the card she draws is 5 or more? So now we want all the values that are 5 or more. So we have 5, 6, 7, 8, 9, 10. And if we're just talking about the numbers, not the face cards, we have 4 suits. So we're going to multiply that by 4. And that would be 6 times 4 is 24. So 24 out of 52. Now once again, if we include all the way up to your face cards. So I think these questions need maybe a little bit of clarification. Jack, Queen, and King. Now you have 9 times 4, and that would be 36. So then you'd have 36 out of 52 as to whether you would draw 5 or more. It does say use a complement, so if we were actually doing it that way, we would take 1 and then we would subtract everything that we had before. So if we were looking at including the ace or not including the ace, we could do 1 minus, let's include the ace, we'll do 16 over 52, and then that would have gotten us 36 out of 52. So a little confusing here because, like I said, I think the way we read this, we could say including face cards, ace, whatever. So maybe some clarification on exactly what we're wanting there with the face cards and the aces. All right, on part C, what is the probability that the card she draws is a red card or a face card? Show how you can use the addition rule to determine the probability. So let's go ahead and use the addition rule. So how many face cards are there? There's 3 face cards. Oh, it has red first. Let's do that first. So red cards, there are 26 red cards because it's half the deck. So we'll do 26 out of 52. There are 3 face cards. So 3 times the 4 different suits. So that's 12. So we'll add those out of 52. But we've now counted some of the cards twice, because out of the red cards, there are a total of 6 that are face cards. 3 hearts and 3 diamonds. So we need to subtract the overlap there from 6 and 52, and then we should get the probability to be 32 out of 52 to draw a red card or a face card, so one or the other. Question 11. Copy the trapezoid below in your paper, then find its area and perimeter. Keep your work organized so that you can later explain how you solved it. Alright, so let's just start with maybe finding some information on the trapezoid that we need. So we have both bases, 22 and 15. We also have the height. So it actually appears that we can go ahead and find the area. So the area is 1/2 times the height times the sum of the bases. So 15 plus 22. So that would be 2. 15 and 22 is 37. So on this one, the area would be 74, and it is measured in feet squared. Alright, so we did that. Now to find the perimeter, we need these side lengths right here. So if this is 15, and you carry this down, so from here to here is 15. We have an additional 7 units left. So this right here will be 3.5, and this is 3.5. And so now we can use Pythagorean theorem to find that distance. So we have 3.5 squared plus 4 squared. We'll just call this A. So that's equal to A squared. So 3.5 squared plus 4 squared is 28.25. Then we can take the square root. So as I was getting ready to calculate, I noticed something in the picture that kind of caught my eye. I did make an assumption about the trapezoid that it was isosceles, and I went back and read, and it doesn't say anything about that. It also says it's not drawn to scale. So I made some assumptions that this leg would be 3.5 and this one would be 3.5, when in reality I don't know that. So I'm going to go back and rethink this here as to how I'm able to find this value. So let's go back to this triangle on the left. It's 45 degrees, and this, we know this height is 4. It is a right triangle. So let's go ahead and find this value over here. We'll call this A. But we're not going to be able to use that leg because I don't know what it is exactly yet. So what we're going to do is we're going to use the, let's see, it'd be sine. So we'll use the sine ratio. So sine of 45 degrees is equal to 4 over the hypotenuse. And then we can multiply both sides by A. And then divide by whatever sine of 45 degrees is. So A then will be approximately 4 divided by sine of 45, and that's approximately 5.66. So we now know this is about 5.66. We can also use the tangent ratio to figure out this leg of the triangle. So that'd be tangent of 45 of 4 over x. You might remember tangent of 45 from your toolkit, but let's go ahead and multiply. If you do know what tangent of 45 is, or you plug it in the calculator, it will be 1. So when you divide by 1, or tangent of 45 degrees, you'll get x equals 4. So my assumption that I made earlier was incorrect, because this is, and this is a 45, and it makes sense that these two legs of the triangle, since that's 45 and this is 45, they have to be the same. Which means now, if this is 15, that's a total of 19, because this is 15 up here, and the total is 22, so this has to be a 3. And now we can use Pythagorean theorem. 3 squared plus 4 squared is equal to, let's call that B. Whoops. B squared. 9 plus 16 is 25. Take the square root, and B is equal to 5. So I definitely had to do a little bit more work there than I initially thought was going to happen. And so now we can find the perimeter more accurately. I'll start with the top. 15 plus 5.66 plus 22 plus 5. And now when I add all that up, I get a total value of 47.66 feet. So, there we go. Took me a little bit longer, like I said, than I thought, but I made a mistake originally. So make sure you are reading the question and not making any assumptions about the picture itself. Question 12. Solve each of the equations below for the given variable. Be sure to check your answers. So in part A, I'm going to go ahead and use the distributive property. Combine my like terms. Subtract 4x, subtract 9, divide by 4, and x equals 3, negative 3. And so to check, we would plug this back in. This would be 4 times 2 times negative 3 is negative 6. 4 times negative 3 minus 3. So that would be negative 6 plus 5 is negative 1 times 4 is negative 4. And then that would be negative 12 minus 1. So negative 4 minus 11 is negative 15. And then negative 12 minus 3 is negative 15. Sorry for writing so small there. Probably should have showed my check a little bit lower down there. But it does check out. Part B, we can multiply by 190. Common denominator for 19 and 10. We can use 190, and if we do that, that'll leave us with 10 times 2m minus 1 is equal to 19m. So 20m minus 1, or minus 10, sorry, equals 19m. Subtract 19m, that's m minus 10 is equal to 0. Add the 10 over to the other side, and 10 is equal, or m is equal to 10. So to check that, that would be 2 times 10 minus 1 over 19 is equal to 10 over 10. So 20 minus 1 is 19. 19 over 19 is equal to 10 over 10, or 1 is equal to 1. So it does check. Part C, 3p squared plus 10p minus 8. It is a quadratic, so we could either decide to probably use the quadratic formula or try to factor it. I'm going to go ahead and see if I can factor it here. I know this is 3p squared and this is negative 8. I'm looking for factors of negative 24p squared that are going to add to give me 10p. So it looks like that would be 12p and negative 2p. So put those in the other two spots and then factor your way through here by 3p times p gives you 3p squared, so that means this would have to be 4, and then p times negative 2 would be negative 2p. So we are able to find our factors p plus 4 and 3p minus 2. Set our factors equal to 0. Get two answers, p equals negative 4 and p equals 2/3. And those are our solutions, and you can plug those back in and check as well, and they will work out. Alright, on to the last one, D. I'm going to see if I can squeeze it in right here. So, since we have a square root and it's by itself, we can square both sides, and that will leave us with x plus 2 is equal to 25. Subtract 2, and x would be equal to 23. And you can check that. We would give you the square root of 23 plus 2 is equal to 5. That's the square root of 25 equals 5. So 5 equals 5. So there were 4 different equations, really 4 different things that we were looking at: square roots, quadratics, linear, and then we even had a proportion here set up as well for part B.